السلام عليكم ورحمة الله وبركاته. I am Maad Ghouti. I'll be showcasing my computer vision project for the CS370, I think 370 Introduction to AI course. First, let me start with the demo, if I can find it. Yes, this is the final outcome, the project. Great. As you can see, there are some mistakes. There are some positives. For example, over here we can detect the alarm bell as a ball, and we can, and if you see right over here, when the balls are in the basket, they're not being detected. We'll address these points at the end of the video. Okay. I'll just start talking about the data set. The dataset I personally annotated using RoboFlow. It took me about 3-4 days, spending hours and hours on annotation. As you can see, I annotated the basket and the ball for each of the images. If I'm not mistaken, RoboFlow, I use the automated annotation for some of the images, but for the most part, I annotated them myself. And for the training, I tried to train it using the darknet library. I was trying to train شو call it YOLO V3 a YOLO V3 model, but unfortunately I ran into some issues with the runtime because I was training on Google Colab. So what happened is I was training for a long time, almost 3-4 hours, but because I'm using the regular version of Colab, told me that I have exceeded the limit GPUs used. So unfortunately, I couldn't train. But I'm pretty sure it did save some backup. It did save some. I can find it over here. It saved some versions of the model while training. For example, you can see the loss of the model while training across thousands of epochs or iterations. I mean, iterations, yes, not epochs. I noticed that every time I trained, I always faced an error at 85 epochs. That's where I used to reach the limit. But I guess, yes, yeah, forget what I said. What I was saying. Okay, so for the training, since the YOLO V3 wasn't working for me, I switched to the updated version, YOLO V8 model. I was able to train it. The main thing I did was lowering the number of epochs, not because of like I said, 80 was almost the limit for Google Colab. So, like as you can see here, 88 and it stopped at 88. I also faced a problem that it wasn't saving. It was saving the runtime of Google Colab. So whenever the runtime crashed on me, everything was lost. Even the models that were saved were lost. So I had to fix that myself. As you can see over here in the training, let me go down. Yes, I have to set the save true and give it a directory to save it. Where was it again? Yes, as you can see, I lowered the number of epochs to be able to be within the limit of Google Colab. Okay, yada, 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 yada. Let's get to the code. Main code. Okay. So in the main code, I created a class for each object I wanted to detect. Since I'm doing detection for so since I'm detecting two different things, the players and the ball and the basket, and as you remember, my dataset didn't include the players; it only included the ball and the basket. So what I had to do was I used two different detectors or trackers, keep track of the ball and the players. So I use the tracker for the player. It's generally just a regular code you can find. I wrote myself, but I was able to find similar versions in GitHub. Basically, just to identify just to get the detections from the model and apply and just draw rectangles around the player. If I'll go over here, this one is I wrote this code for the my own model because it gave the results for the basketball and the rim itself. So if you can see over here, let's say for each detection for each frame, you'd get the coordinates x and y for the boxes. You get the top right corner and the bottom left. Yes, top right corner and bottom left corner. The opposite side. Top left and bottom right. Yes. And get the name for detection. So as you can see over here, you get the basket and ball. Let me go down. Here I detect for each frame, and here I detect for all the frames. I'll go over the pickle later. So over here you can see that drawing the boxes, same as the players. The only difference is I check the name of the detection. If it's a ball, I give it different color. That's it. Let me go back to the main. Yes. Here, as you can see, you have the player detection. So here I'm detecting the player using a YOLO V8 model, which is trained on, I'm pretty sure, Coco, a Coco dataset, which includes like 82 different objects. That is heavily trained. And here I'm doing the ball tracker using my own dataset that I trained. You can find it, as you can see, yes, over here. It came out with two models, the best and the last, but I compared both. It turned out that they are the same model. The last model was the best model for me. Yes, so I detect the players in each frame first, and then I detect the ball, and then I draw them. I draw the boxes around the players and around the ball, and then I save the video. That's about it for the code. It's pretty straightforward, pretty simple. I have a utils folder for the utility to read the videos and to read the video and save the video. Nothing too crazy. And one more thing. After training, you can find a lot of useful information. For example, you get the confusion matrix for the testing and validation, the F1 curve with the confidence, and for example, yes, the results, the train, the class loss, the class validation loss, and the box loss. I will not go into the details on how YOLO works, but basically it does two things: regression for the boxes, because it's you can think of it like at a regression for the values, for the X and Y values for the boxes, and the classification just to differentiate between the different types or types of objects we have. Yes, and for the errors that I might have faced or the models might face are the confidence levels, because the confidence heavily affects what is bounded and what's not. Like as if you remember in the video over here, the rebel over here is considered a ball, which is obviously not, because the confidence threshold I have it set to, I think, 0.15. If I increase the confidence threshold, it should solve this issue. And the issue for the when the balls are in the basket, one solution could be that I have a different. I augment my data set with images where the ball is in the basket, and I tag them or annotate them with this, with the identification called ball in basket or anything. And this is it for my project. I hope you enjoyed the video, and thanks for watching.